UiPath Studio is one of the best low-code, no-code RPA tools available in the industry right now. But after all, it is a programming tool, which means sooner or later it might run into some problems, some exceptions, and fail, which also means we need some sort of recovery mechanism built into the studio. And the official activity for exception handling is called try catch block. And a good understanding of this fundamental concept will definitely help you become an awesome RPA developer, which is what we are going to do in this video. So I was helping someone with try catch block the other day, and when I tried to find a YouTube video that would explain the concept quickly and well, most of the videos that I found were either too long, or the short ones, they just didn't cover everything, or at least they didn't cover everything that I thought they should cover. And that's why I thought, why don't I make one? And this is that video. Now, the try catch block is not a UiPath only concept. It's been around for quite a few years, and also it's common to many programming languages. And to make it easy to understand this concept, we are going to run a thought experiment. And to run that thought experiment, let's fuel up our brain first. Now, imagine a building, say 5 stories high, and on each floor there's a deck or a balcony. And imagine that on each floor, one person is standing on the deck wearing a baseball glove. The person on the roof throws a ball up and tries to catch it. But for the sake of this example, let's say they're playing a game where the ball must not touch the ground, because then someone's gonna have to go and get it. If the ball isn't caught by the same person who threw it in the air, then the ball naturally drops down, and the person standing on the deck one floor down will try their best to catch it. And if not caught there, the ball drops further down to the next floor, and so on until either someone catches it or it falls to the ground and it's game over. Got him. What we just visualized is called exception propagation. You see, anytime UiPath process is executing and it calls another workflow, control of the flow is passed from one workflow to another workflow, so that we can say exactly where the control is or where exactly the flow is in its state. For example, when main.xaml or main.xaml file in your UiPath Studio calls another workflow, the compiler, that is the guy who is in charge of running everything smoothly while a UiPath process is executing, that compiler creates an app stack, which is sort of like a registered memory of every call that was made by one workflow to another. It's a sequential memory of how the control was passed from one workflow or one piece of code to another. And as the innermost call has finished execution, that is, it has served its purpose, the top floor of the building will get removed, and the compiler can then work its way back down to pass the control back to the original calling workflow or original calling piece of code. And that's how, once all the different floors of app stack have been removed, the control comes back to the ground floor. And once main has finished execution, the building basically gets deconstructed. That's how you can visualize what an app stack is. Now, if no exceptions occur during the execution, then the building, that is the app stack, gets constructed and deconstructed automatically, and we don't even have to think about it. If, however, there is an exception, in that case, as long as someone on one of these floors can catch the exception, catch the ball, then the game can continue. And even better, the guy who catches the exception, that catches the ball, gets to decide what to do with it or how to handle the next part, whatever happens next. And to see this process in action, we are going to now jump into UiPath Studio and see how a try catch block actually functions and what it looks like. So let's get into it. Before we see a real example of try catch block, let's consider why we might want to use it in our program. When we build a UiPath automation, it typically involves a few different activities from different activity packages. And depending on what that activity is doing, it could throw a different type of exception. For example, a database related activity might run into connection problems, whereas a UI automation activity may fail because it fails to find an element that it is trying to interact with. Every activity has its own potential problems, and to mitigate these problems, we use try catch block. Now let's see how that actually looks. I have here a potentially problematic code sequence. It has a few different activities, a couple of database activities that can throw a SQL exception, a log message activity which is calling a variable that may be empty and throw a null reference exception, and I have a couple of file related activities which may throw a file not found exception or a file IO exception, which means it fails to read or write into that file. If I run this program and it runs into one of the exceptions that we just listed, I may want to control what happens to the flow, what happens to the execution based on the exception. And that's what a try catch block allows me to do. If you look at the try catch activity, it is divided into three main parts: try, catches, and finally. The try section defines what you want your program to do. The catches define how to handle if a problem occurs, that is exception handling. And finally is the block which allows you to clean up, allows you to do some of the things that must execute no matter whether an exception occurs or not. Now I have already prepared a try catch block so that we can handle all the exceptions that we just listed before, and I'm going to drag my potentially problematic code sequence into the try section of this block. Now I have a few different catches defined here. If we think back to our building analogy, what we are saying with try catch block is the person who has the ball on the top floor has three choices when a problem occurs. They could catch the ball, act like nothing happened, and let the game continue, or they could catch the ball, do some corrective action right then and there, and then let the game continue, or they could just drop the ball, let someone else handle it, or let someone else catch it. Back to our example, let's say there was a problem connecting to the database and a SQL exception was thrown. Now on the SQL exception floor, I have three choices. I could literally not add an activity here, meaning act like nothing happened and let the game continue. So anything that is going to execute after this will continue to execute. Or I could try to reconnect, I could just skip that part altogether and let the game continue, or I could just completely skip the SQL exception part and the exception block will rethrow that exception further down, which means it goes down to the ground floor and someone else will handle it. Note that my catches section has an additional exception block which is of type exception. Exception is the superclass, it's the parent of all different types of exceptions. So any exception that is not one of these four types will be caught by this block, so that our program is protected against any type of exception, not just the four that we actually expect to encounter. This exception block doesn't necessarily handle it there, but it records the exception and then throws it down towards the ground floor and someone else will handle it. Now let's look at the finally section of the try catch block. The finally section allows the robot to perform some activities which must be executed whether or not there was an exception. For example, in this sequence, let's say a database connection was successfully established, but when the robot was running the query, for some reason the query failed. Now we still have a live connection that we achieved from this connect to database activity, and we still need to close it. If I add a disconnect activity after the run query, it may execute only if the query is successful. If there is an exception, the exception will be thrown out, the SQL exception block will catch it, and then rest of the sequence will not execute. On the other hand, if there is an exception and I add the disconnect from database activity here, there may never be an exception and the disconnect will never execute. The alternative would be to include the disconnect activity in every place. That's also not recommended. The finally section solves all these problems. What I simply say is, if there is a live connection, disconnect from database. Simple as that. This and any such activities can be added to the finally section so that we can always have a clean exit after a sequence has finished either successfully or with an exception. So that was a quick introduction to exception handling in UiPath Studio using try catch activity. I hope you found the video interesting and helpful, and if you did, please forward it to 3 more friends so it also may help them, and also hit the like button so YouTube gods will know that they need to show this video to more people and help them. Thank you and happy automation.